Hello and welcome to a ramble with me. We are looking at the final question in this series at last. Oh my gosh, I never thought this day would come. Genuinely, genuinely. So we are in IEB paper 2 of May 2024 and we are looking at question 13. And of course I say it's the final video for the series, but you are always most welcome to ask me to clarify something from a video that I've posted, or to do a video on another question that I maybe haven't covered in the series. I will generally be happy to do that, unless it's stats. Then I'll be very upset. But I might still do it. Anyway, so question 13, here we go. In the diagram below, the sides of triangle ABC, pointy thing, ABC, touch the circle with center O at D, E, and F. D is the midpoint of AB. AD is 8 units. Okay. Whoa. This is 8 units. This guy over here. Oh my gosh. Okay. And EC is 21 units. Okay. Determine the size of angle ABC. ABC. Okay. So first up, these are tangents, right? So there's a whole lot of equal tangents going on, right? Because this and this will be equal, this and this will be equal, this and this will be equal as well. There's also a center, so there's opportunities for us to draw in some radii. Possibly that might be helpful, I don't know. Anyway, we're looking for the size of angle ABC. And we can use the cosine rule for that, because we know the length of this side is 8 and 8. We know that this is also 8 because of equal tangents, so then we know the length of this side. And then we know that that's also 8 because of equal tangents, and that's 21 because of equal tangents. So we know the lengths of all the sides. So we can work out the angle ABC using the cosine rule. Let me try to think if there's something else that immediately jumps up at me. Nothing immediately jumps up at me, so it's gonna have to be that. I mean, I'm thinking of connecting this cord here, but I don't know what it will serve us, because we'll only have this length and this length. We don't have any angle sizes, or I don't know. Anyway, so I'm just gonna go right ahead and listen to my heart. Listen to your heart. I like this little purple situation. Let me replace this yellow because it is irrelevant. Way too pale for the page color we work with. This green is also way too pale. What shall we replace you with, my friend? Brown? It's giving no. I don't ever really use black. Yeah, come on now. Yeah, let's get in there with some black. Right, so first off, I'm saying that BD is equal to AD is equal to 8, which is given to us. Okay, so we know that that's also 8. And then AF is equal to AD as well, is equal to 8, because equal tangents AF and what's the reason? Is it equal tangents? I don't know. I'm gonna make up my own reason, because I this equal tangents is not giving me happy feelings. So tangents from common point A. Okay, so that's also 8. And then we know that BE will be equal to BD will be equal to 8, and that will be tangents from common point. The common point this time is B, right? So from here we get this tangent and this tangent. Okay, so now we know that that's also 8. And then lastly, we know that CF is equal to CE is equal to 21. And that is because tangents from common point C now. Okay, and now all of that being said, therefore AC is 8 plus 21, which is 29. This is me being lazy to go to a new line. BC is equal to 8 plus 21 as well, which is 29. And then lastly, AB is equal to 8 plus 8, which is 16. Okay, so let's just fill that in over here. So this is 29, this is also 29, and this is 16. Right, and if we label the sides of our triangle using our trig conventions, this side is little c, right? It's opposite to the angle C. This side will be little b, and this side will be little a, right? And we are interested in the size of angle ABC. So the cosine rule says b squared is equal to a squared plus c squared minus 2ac cos of b. Okay, definitely gonna need a new page. So let's just organize that. Right, and if we rearrange that so that we have the angle stuff sort of chilling by itself. Okay, right, so done a lot in one step there, but we've minus a squared on both sides, minus c squared on both sides, and then you're just left with this term, right, on the right hand side. So then you divide by this coefficient on both sides. So that's how we've ended up with that over there. So now we can slot in all our stuff. So AC is our little b, BC is our little a, and AB is our little c. Right, so b squared is 29 squared, a squared is 29 squared, and c squared is 16 squared. And then down here we have minus 2 times a times c. Okay, right, and let's see what we get. Oh, Calci was taking a little snooze. So we have 29 squared minus 29 squared, so that's 0. 16 squared is 256. Okay, and then here at the bottom we have negative 2 times 29 times 16. So we end up with, cos B is equal to 0,275 blah blah blah. And because we're working in a triangle, in terms of cost, we don't care about these quadrants, right? Our angles are between 0 and 180 strictly. So, and because now the cos value of this angle B is positive, that also now eliminates this quadrant, because if the angle was obtuse, then the cos value would be negative. So we can just straight up do our young inverse of cos operation. So we're just gonna plug in here the angle b will be inverse of cos of this big beautiful number. So let's just go ahead and do that. Shift cos of my answer. So that is, whoa, okay, if I round that off, that is going to be about 74,0 degrees. I'm going to store this answer because who knows when we're going to need it. Shift store. I'm going to put it inside P because that feels more natural. Righty dighties. Cool. So we now know that this angle over here is about 74 degrees. Next question. Determine R, the radius of the circle. Ooh, exciting stuff. How do we do it? How do we do it? So, I mean, definitely I'm inclined to, you know, connect the center to one of these, you know, tangent points and then seeing what happens. Another part of me also feels like, you know, whenever they talk about working out the length of a radius, I just immediately think of that theorem, you know, a line from center of circle and, you know, the perpendicular, and then you work out the length of the radius, wondering if that might come in handy somewhere. And actually it might, yes, because if we have the size of this angle, okay, and we know that this is 8 and this is 8, and then we can work out the length of this side using what would we use? Oh yeah, we'd use the cosine rule, of course. Cosine rule, if you have two sides and an included angle, then you can use the cosine rule to work out the length of the other side, and then you've set up like pretty much your standard question with this theorem, right? Where we know that, okay, this whole thing is R, right? And this is R, and we would know the length of this guy. Oh yeah, but then it's a flop because you don't know how long this little bit is here over here, you know, or this bit for that matter. So it's a pisang popo. So never mind, I got too excited way too quickly. You know, it might end up coming back to that. Who knows? Let's see. Next idea, Thamzozo. So, this did feel quite nice though, having this chord here and the prospect that I can work out how long it is. And then, you know what? If I draw these radii in, we already know that these are equal from, we previously determined that. These are equal because they're both radii. So then this shape here is a kite, and I know that kites, okay, I was about to say I know the opposite angles are supplementary, but that's a lie, because then that would mean these ones are also always supplementary, which would mean because they're equal, that's a property of the kite, that they would always be 90, and we know that's definitely not true. So yeah, I was about to lie. I was about to tell a big chunky lie. Anyway, I still like this. It's giving me promise. Let's see. So we know the size of this angle. We know that's about 74 degrees. And we can work out the size of these two easily, because isosceles triangle vibes. And then what must happen? What must even happen from there? Nix. Well, these are tangents, so then I'm thinking tan-chord, right? If I were to draw my own imaginary angle in the alternate segment, then this would be dot, you know, and then this angle at center will be double dot. And with that information, knowing that these are equal, I can again use the cosine rule, because I would know how long this is, right? So then I can use the cosine rule to say, well, you know, r and this included angle somehow need to give me this side. That seems like quite a stretch, Miguel, but you know, it works. It is an approach. I'm keen on that. So let's just talk about this. Let's just talk through this again. So I said, we know that this is, okay, so first I construct this chord. And then I work out its length using the fact that this is 8, and this included angle, we know its size. So then I can work out the length of this guy. Okay. Then from there, I said, I am constructing this angle at the center, okay, and recognizing that, okay, this is an isosceles triangle, which will come in handy later. Thirdly, I am constructing an angle subtended by this chord in the alternate segment to either one of these guys, doesn't matter which one I choose, because yes, we've got a tangent here and a chord here, so this angle or this tangent and this chord form this angle. And if I subtend now an angle at the circumference from this chord, tan-chord tells me that these will be equal. And it is easy to work out what each of these is equal to because there's an isosceles triangle and I know the size of this guy. So then, knowing that, and then I subtend an angle at the center from this same chord. So then angle at center tells me that this angle will be double this guy. So now I have the length of this chord, I have the size of this angle. I know that these two are equal. I don't know what they are, but I know that they're equal in length. So then I can use the cosine rule to figure out, yeah, the r, the value of r. Am I walking past a simpler way to do this? Wow. You know what? I'm committing. It is late at night. My brain is fried fish. Right. So step one, we said, okay, I'm just going to outline this little plan. So first we're going to construct. Okay, so I'm going to write down all the steps. Construct chord D, E. And use cosine rule to calculate its length. Okay, so that's step one. Step two. From there, we are going to determine size of angle BDE. I'm so excited to see how the memo does this because I feel like this is going to be one of those questions where there actually are like a million ways to solve it, and it's going to blow my mind to see all the ways that the memo is going to offer. Anyway, then construct, you know, I could even like choose not to make it go to a random place. I could actually just use a point that has already been given to me. Maybe let me do this in a different color. So let's use F. This so it's easier to name, you know. So construct DFE and determine its size. I don't know if I've ever done so many constructions in an answer to a geometry question. I'm usually so heebie-jeebies about doing constructions. Next up, we wanna, this is horrible. Oh my gosh, I you know what? I'm just gonna draw this from scratch because wow, Wow. Okay, so first we want to construct DE. It's not great, but at some point I need to accept my imperfections in life in general. Is that orange? It's not giving orange, honestly. Okay, right, so that's the first step. And then the second step is to determine the size of angle BDE. Let's do that with a green and then highlight it in green. Yeah, this green is going to be very bright, so it's not really giving matching, but you know, whatever, I'm trying. Then next up we want to construct DFE. Okay, and determine its size. So this will also be using tan-chord, it will be equal to that. I'm just going to actually call this dot and this one dot. Then fourthly, is that even a word? Where my pen colors, man? Okay, fourthly, we want to construct DOE and determine its size as well. Okay. Yo. Disasters. Okay, but actually not bad. I'll take it. Okay, so that actually turns out to be double DFE. And then the last bit is to use the fact that these guys are equal. Use isosceles triangle DOE and cosine rule to determine R. Oh my gosh, I am loving my color-coded strategy. I feel so good. I feel so much clarity in my spirit. Let's go right ahead and launch in. So starting with step 1, we said that we are constructing DE and using the cosine rule to calculate its length. So I don't know if I said cosine rule or if I just said cosine. I'm just going to draw this triangle for us because anyway, moving right along. Points for effort, my girl. Points for effort. So this is BDE. We know that these are equal. They're both 8. And this is about 74 degrees. And we're trying to find the size of this guy. So again, using our little trig convention. Okay. We can then say that b squared is equal to e squared plus d squared minus 2de cos of angle B. Right, so in other words, de squared is equal to 8 squared plus 8 squared minus 2 times 8 times 8 cos of, it's actually going to be, what was that number exactly? It was 73,9 something, right? How do I do this recalling thing now? 73,9 something. Okay, right, so now let's put that all into calculus. Okay, and we get 92,6 blah 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 And then that tells us that DE is the square root of that, and we only think about the positive square root because we're talking about length, so it can't be a negative number. So that is 9,26. What did I see that right? Whoa, calculate 9,627. Oh gosh. Okay, so we are definitely going to need that number later on in our lives, and I'm going to store it yeah, B would have been a nice candidate, but unfortunately not available. So we're going to say shift store in A. Okay, so let's see if everything is still intact. A looks good, B still looking good. Okay, so just make a note to myself that this is stored inside A. Okie dokie. So now for step 2. Step 2 says determine the size of angle BDE. Okay, so what color is that? Green. Okay, so step 2. Okay, so again we're looking at this triangle. Let me see if I can copy her. Oh, just copy everything. Okay, so next up we're trying to figure out the size of this guy. Okay, so we know that angle BDE is equal to angle BED because base angles of isos triangle BDE, right? So let BDE and BED equal to x, then that means, so in other words, this is x and this is also x. Whoa, flying creature. Then angle B plus x is going to be equal to 180 degrees. Angle sum of triangle BDE. Okay, and that'll mean 70, what was it? It was 73 comma, I feel like I'm asking this question so many times. Plus 2x is equal to 180 degrees, so then 2x is equal to 180 degrees minus this number, so then x is going to be equal to okay, jumping schnimmenem 106 comma, yay man, 0 something something. So then x is going to be a half of that, which is 53 comma 0 something something something. That I am going to store inside C. Shift store C. Okay, so let's see, successfully stored. Yes. Okay, so we now know that this is 53-ish degrees. Okay, And I'm just gonna bring this diagram right across. Oh, it's gonna come across with so much baggage. Oh my gosh. But it has to. What's going on? Did you do my duplicate? No, you did not. Did I say duplicate? Am I losing my mind? I don't think I said duplicate. Hey, Bandla, why are you not duplicating? Okay. It's giving gaslighting, guys. Not feeling this energy at all. Okay. Right, so we have done the orange part of our plan, the green part of our plan. Next up, we said that we want to construct DFE and determine its size. Okay, so that is the next part of the plan. Right, so DFE is equal to BDE, okay, i.e. BDE, that angle, DFE, that angle, and the reason is because of tan-chord, the tangent being this guy, ADB, and the chord being this guy, DE. Okay, right. So we now know that those two are equal, and we know what the size of BDE is. We know that it's 53,0 something something degrees. Right. So then next up, it's time for the blue step, which is the angle at the center. So angle DOE will be equal to 2 times angle DFE. And I'm going to write the reason here and then I'm going to squish it. Angle at center, right, is equal twice the angle at the circumference. I'm going to make it a little bit bigger. Right, so that's going to be 2 times the 53, whatever, and that'll be 2 times C, which is the 106, 0 blah 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 degrees. Yeah, I'll store that. Let's store that inside D. Okay, double check, correctly stored, yes. Oh, we have already stored this number, haven't we? Have we? I don't know. Anyway, I don't think we have. Okay, so then next up, we are ready to set up our last equation, right? The last part is step red. Use isosceles triangle DOE and cosine rule to determine R. Right, so just to now draw what we're dealing with. Okay, we have okay, I'll keep it kind of oriented the way that it's oriented. Oh yeah, no, those R's are not looking very equal. My apologies. So we now have over here 106 degrees or so. We have the length of this, which I have forgotten now. We calculated that first. DE is 9,627 blah blah blah. Okay, and we're gonna have to explain why we know this, but we know that these are equal. And so using our cosine rule, we know that this squared plus this squared minus 2 times this times cos of this is going to give me this squared. So first up, let's label, that always helps. Okay, first up we're going to say DO is equal to EO is equal to r, right? Because these are radii, and the r came from the question, you know, it said determine the radius of the circle r. So right, so then we use our trig nomenclature. I don't know if that's a legit way to use that word. So this will be d, which is equal to r. This will be e, which is equal to r, and this will be o, which is equal to that beautiful number. Okay, so we know that the trig says o squared is equal to d squared plus e squared minus 2de cos of o. Now you can sub in all the stuff that we know. So this will be the 9,627 blah 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 squared is equal to r squared plus r squared minus 2r cos of 106 comma blah blah blah. Okay, righties. So I am not going to punch anything into the calculator just yet. I want to try and, you know, get this you know, manipulate the equation as much as possible before I do that. Please do not fall for, you know, what feels like is waiting to just be done. 2r squared minus 2r squared. No, don't do that. This 2r squared is in a very committed relationship over here. This is a term, so you can't just randomly minus it from there. What must happen with the rest of the household? What must happen? Don't do it. So what we are going to do instead is factor out the common 2r squared to both terms. Right, and then from there, this is just a number, so we can go right ahead, and that pencil is way too bright to be included in this palette, honestly. Let's see if we can get a nice vibrant blue, something like that. So I can now divide by this number so that I can isolate, you know, almost, well, actually I can even divide by 2 times that, right, so that we also cancel this guy. And then I just need to do it on the other side as well, because, okay, no, I was gonna just try and copy paste, but it's just gonna end up being more work, because now I have to resize it so that it fits on this side, because why am I writing like Frankenstein on one side, but then on the other side I'm writing like, I don't know. Okay, so r squared is equal to this number, which I have forgotten where I stored it. Okay, righties, that's our r squared. Okay, so let me see, it's the 9,627 here. Yes, it is. So my 9,627 is in A. Where is my 106? It's over there. Nice, very good guesses. Right, so this is gonna be the a squared divided by 2 times 1 minus cos of d. No, what am I doing? Cos of d. Okay, so that is 36,3 blah blah blah, and so the r will be the positive square root of that. Why are we not thinking about negative square roots? Yo, why am I still using degrees? Right, we're not thinking about negative square roots because the radius can't have a negative limit. Okay, right, so our final answer comes to about 6,0. I don't know what units we were using. I think we were just using units. Right, our units are units. And that is my final answer. Yo, wow, okay. That was a lot of fun. It's gonna be completely heartbreaking if it's wrong. Right, so let's hope not. Let's see what the memo thinks of our endeavors. Okay. I think we got it right. Okay, so let's see what they've done here. So for the first one, they have used the cosine rule. So we've looked at that and they've reasoned about it the same way. So using the tangents from a common point, they worked out the lengths of, all the unknown sides, and then they used the cosine rule. Awesome. The second one, though, they have done a much simpler approach. We've arrived at the same answer, which is a relief. I'm so glad. But they have a much simpler approach. Let's see. So they say, I feel like I need to have a clean diagram so that we don't confuse approaches here. Oh my goodness, what is the time now? I don't even want to look. Okay, so they say area of BOC is given by half of 29 times R. Ooh, okay, I definitely need to draw this. So they construct this triangle. Okay. Something like that. And they say, okay, we know this length. That's 29. And this OE is the perpendicular height because of tan rad. And if we call that R, then yeah, we know that the area of this triangle BOC will be half of 29 times R. Cool. Then they do AOB similarly. Okay. And they construct that perpendicular height. Again, R is that perpendicular height. And this one, the length is 16, which we previously determined. And then lastly, they look at AOC. Okay. Whoa. Oh, that's quite nice actually that you can do that. Post-production. Okay, so then they construct this perpendicular height. Tan rad tells us that it's perpendicular. This is another radius, and the length of this side is also 29 as previously determined. Right, so now they have formulas for the area of these. Oh, very nice, very nice. Okay, so then they set up an equation, because they then say, okay, the area of the red triangle is half times 29 times R, and then the area of the pink triangle is half times the base 16 times the height, which is R, and then the area of the blue triangle is half times 29 times R as well. And they say, well, this is equal to, you can use the area rule, the trig area rule, because we have this side, we have this side, we have this angle. So that'll be equal to half, okay, we need to move this. Move up, these girls are taking over. Hey. So that'll be half of 16 times 29 times sine of B, which is the 73, whatever. And then you solve that equation, which is just fantastic, absolutely beautiful, nice, clean way of doing it. I love it. Oh my gosh, I'm in love. I'm gagged, guys, I'm gagged. Right? They also offer us a second approach. Let's see. Let's just go through the second approach that they offer us. So second approach, they say angle A is equal to angle B. Okay, yes, because this is an isosceles triangle. These two have the same length. They're both 29 units long. Okay, cool. So now that we know that, they say, but AFO is congruent to AGO. Really? Is that true? Let's see. So they have a common side. And then these are equal. We showed that before. And then these are both R. So that is the truth. SSS. These two triangles are in fact congruent. So therefore, this 74 degrees gets split. It's being bisected by AO. Okay. And then what do we do from there? Since OF is perpendicular to AF because of tan rad, then we can use SOHCAHTOA. Oh my gosh, that's so clever. Yes, because that would be 37 degrees roundabout, right? Half of 74. And what? Oh, we know the length of this one is 8. So then in order to work out this guy, we are doing, this is the angle we know, this is adjacent, and this would be opposite, so you'd have to use tan. Oh my gosh, that's so elegant, that's so beautiful. Ooh, ah. Absolutely stunning. Oh my gosh, my heart is completely molten. Right, so that was really a very, very beautiful question to end the paper off with. I hope you also had an exciting solution, an exciting way of thinking about this problem. And yeah, I feel like, some of these things, it really does just come with more and more practice, right? Like your brain just gets to build more neuron pathways. I might be abusing the language a bit there, but as you practice more questions, your brain just starts building up this database of different approaches and things you can try. And you don't even realize that it's drawing from question whatever of this paper and question whatever of that other paper and this exercise that you did inside the textbook. The brain is just amazing like that. Anyway, so I'm saying this to say if you didn't see a way to solve it, or if you hit many dead ends and you're kind of beating yourself up, please don't. And don't give up on practicing. It will bear fruit, and it is bearing fruit. Yeah, just help your brain along, help it build up these kinds of references that it can draw on whenever next it encounters a question like this, where there's just so much room for creativity and constructions and whatever. Anyway, I hope that ramble made sense. Thank you so much for tuning in, and yeah, catch you next time. I don't even know which paper I'm doing next, but I hope you'll be there. Cool stuff.